So today we're going to talk about solving systems that are a little bit more complicated than the ones we did yesterday. The ones we did yesterday was kind of obvious what we were supposed to do with them. They were in standard form, so like we've discussed, in order for you to use linear combination or elimination, whichever way you want to call it, they have to be in standard form. They have to have an opposite. Okay, so on the ones that we did yesterday, the opposite was super obvious. There was like a y and a negative y, or a 3 and a negative 3, 3x and a negative 3x, or like a 3x and a 3x, but it was really easy to make a zero pair by just multiplying one row by the opposite. The ones we're going to do today are less obvious, so we have to do a little bit more work to get these to work. Okay, so let's take a look at this first word problem. We did a word problem yesterday, so we're going to do another word problem today. You know, word problems are nothing to be scared of. In fact, writing word problems in standard form is super easy. Okay, so let's take a look at this problem. It says coffee conundrum. The Lotta Chocolate Coffee Company packages gift boxes for coffee for mail order gifts. One gift box that sells for $68 contains 6 pounds of vanilla flavored coffee and 5 pounds of chocolate flavored coffee. Another gift box that sells for $43 contains 4 pounds of vanilla flavored coffee and 3 pounds of chocolate flavored coffee. If the packaging is free, how much does each type of coffee cost per pound? Wow, that was a lot of information. Okay, so the first thing I do, there's a lot of stuff going on here. The first thing I do is I go to the question mark, because the question mark is going to tell me what I'm looking for. I want to know how much does each type of coffee cost per pound. So my variables are going to represent cost per pound of a specific type of coffee. Well, I have two types of coffee. I have vanilla flavored coffee and I have chocolate flavored coffee. So they've told me to use V and C, but I'm going to be honest with you, I would have used V and C anyway because they make sense. If I had used X and Y, then I would have been like, okay, X is vanilla or is X chocolate? I would have been wondering the whole time. This way I don't have to wonder. I have the variables and they make sense to the situation I'm in. Okay, so I'm going to say V represents the cost per pound of vanilla coffee. Why not? Okay, so that's what V is. So what's C going to represent? Well, C is probably going to represent the cost per pound of chocolate. It's really important that we define our variables ASAP, like at the beginning. Some people like to write their equation and then define the variables. Some people like to define the variables and then write the equation. Regardless of how you choose to do it, you need to define those variables really pretty quickly out of the gate. Okay. The next thing we want to do is we want to get everything out of the word problems. I don't know about y'all, but this is a whole lot of information. Okay. So right now, what I want you to do is I want you to take a look at the first sentence with information. So the first one, this one tells me my situation. The second sentence tells me about one of the gift boxes. I want you to write an equation for for the first gift box, the $68 gift box. Take a moment to do that right now. Okay, so when I look at that one, I see 68 contains 6 pounds of vanilla and 5 pounds of chocolate. Now you may have written it 6V plus 5C equals 68. Is that right? It's totally right. It doesn't matter which way you write it. Okay, they're both right. Okay, I want you to right now take a minute using kind of what I did there. If you did not get it right the first time, I want you to try it the second time. Let's see if you get it right the second time. Do the one, I want you to write an equation for the $43 gift box. Okay, so the $43 gift box contains 4 pounds of vanilla and 3 pounds of chocolate. Okay, so remember, when we think about systems, if I have two variables, I need two equations to solve for those variables. If I have one variable, I can just use one equation, but since I have two variables, chocolate coffee and vanilla coffee, I have to use both of those equations. Okay, so let's pause for a minute. We're going to take a little step back and we're going to talk a little bit about how we used to solve them. Okay, so this is different than any system we've seen before. Graphing and substitution are terrible methods because if we actually solve this, and some of you tried to do this on the last test we took when we were trying to do straight substitution, and you were like, I'm just going to write everything in slope-intercept form, and it was horrible because you ended up getting all these crazy fractions, and then it becomes so difficult to solve. So if you try to put it in slope-intercept form, first of all, which one's x and which one's y? I mean, that's its own challenge. But if you decide to solve for c, then you get this and this. If you solve for v, then you get these two crazy-looking equations. Either way, you got a whole lot of fractions, and I don't know about y'all, but I don't like those. So I don't even want to be putting this in my calculator, even though the calculator will take care of it for me. Also, if I'm seeing fractional coefficients, I might have fractional answers, which might make it difficult for me to find my answer in the calculator. So, graphing and substitution are out. We also know that I don't immediately in either one of these, I don't see opposite coefficients. So right now, I don't even see the same numbers. I have a 6, a 4, a 5, and none of them are even the same number. So this is already much different. Also, if I multiply both sides of one equation, so if I multiply this one, I can multiply this one by, I'd have to multiply this by 1.5, and that would make this 4.5. It's crazy. I mean, -1, I don't even know. There's no one number that I can easily eliminate a term that will give me whole number coefficients. Because remember, we don't want fractional or decimal coefficients because they're weird and we mess them up. Okay, so let's talk about what we're going to do. Okay, so for this problem, we're going to need to multiply both equations by a factor. Now, the reason why you guys aren't going to like this strategy is because there's lots of ways that I can do this. Let's say I want to eliminate my v's. Okay, I can multiply this one by -2 and that one by +3. And then my v's, I mean everything by, so if I multiplied everything up here by +2 and everything down here by -3, then I'd have 12v and -12v when I ended up multiplying everything out. Okay, that would eliminate the v term. I can multiply this one by 3 and this one by -5. That would eliminate the c term because 3 times 5 is 15, -5 times 3 is -15, and then I have opposite c's. I can multiply this one by 4 and this one by -6 to give me 24 up here and -24 down here. I can multiply this one by 6, well, -6, and this one by 10. That would give me -30 and +30. There are a billion different ways I could solve this. Okay, that's the reason why you guys tend to not like this strategy, but it is a super powerful strategy to use. So we're going to talk a little bit about what to do and how we should do this. Okay, so let's try this problem ourselves. Okay, really quick, let's pause for a moment. I want you to take a minute, and I want you to type in what do you think you'd like to, which variable would you like to eliminate? Take a second and type that in right now. I like what Kayla's got working here. I like that she has the first equation she's multiplying by -2 because it's a small number. The second equation she's multiplying by 3, that's a smaller number. Those are the smallest numbers I see that I can multiply by, and they're gonna make it easier for me. I'm gonna have smaller numbers to deal with. I'm not gonna freak out because I see humongous numbers. Okay, so I'm gonna do -2 times 68 because again I like to get the right answer. This turns into -136. -2 times 6 is -12v. -2 times 5 is -10c. So I've got this one done. 3 times 43 times 43, because I like to get it right. This turns into 129. 3 times 4 is +12v. 3 times 3 is 9c. Now this is what I'm working with. Do I have a zero pair? Yeah, I got a zero pair right here. So that zero pair zeroes out, and I'm left with only c variables. So I'm going to do -136 plus, hang on a second, 129, and I get -7. -10 plus 9 is -1c, and I get 7 equals c. So that means my pounds of chocolate coffee, $7 per pound. I know that right now. I suspect that. I'm gonna find out how much vanilla coffee costs, and then I'm gonna confirm it with this last equation. Okay, so 68 equals 6v plus 5c, which is 7. 68 equals 6v plus 35. It says 6v equals 33, and I get 5.5 equals v, which kind of freaks me out a little bit. But you know what? I'm not going to assume that I'm wrong until I check it. I have a whole nother equation right here to check with. I'm always going to check before I see a fraction and freak out. Okay, so I'm going to use that one. 43 equals 4 times 5.5 plus 3 times 7. And for this one, since I got decimals, I'm just going to stick these directly into my calculator. 4 times 5.5 plus 3 times 7 is 43. I have a true statement there, so that means that vanilla is $5.50 per pound, and chocolate is $7. Except that's LB, not BL. I don't know what happened there. And there's my answer. Remember, word problem, I need a word answer. Okay? So, I want you, I'm going to give you up a little pop-up window, and I want you to describe to me what I had to do that was special in this problem. What was different about what we did yesterday? What did I have to do, hint, to both equations, in order to solve this problem using linear combination? Okay, so what I'm hoping that you guys came up with is, in this case, because I didn't have a zero pair jump out at me, I had to multiply both rows by a coefficient. So I had to scale up both of these equations in order to create a zero pair. Remember, as long as I multiply the entire equation, every term in the equation by that value, it's going to be okay, and it is a legitimate way to solve the problem. Okay, let's try this one down here. I'm going to actually, I want you to try this problem. I'm going to give you a moment, and I want you to try this problem, and then I want you to enter the answer in the little window that pops up, and then what you think the answer is, and then I'll go through it when you come back. Okay, so when I look at this one, right here, I'm drawn to this because I already see opposites. So that tells me that I don't have to multiply by negatives in order to get an opposite. See, I have a positive and a negative y. So what would their common, what would the common multiple be? Well, if you don't know, multiply them together. 3 times 2 is 6. So for this one, to get to 6, I got to multiply everything in this row by 3. To get this to 6, I got to multiply everything down here by 3. Does that make sense? So I'm scaling up the y's because they're opposite. Now, could you have multiplied this by 5 and that by -2, or that by -5 and that by 2? Yeah, totally. There's lots of different ways to do this. This is the way I chose because I'm lazy and I'm freaked out by negatives, and so I see an opportunity to not use them and I go for it. Okay, so I'm going to transform these now. 2 times 2x is 4x. 2 times 3y is plus 6y. 2 times -1 is -2. Let's try this one. 3 times 5 is 15x. 3 times -2 is minus 6y. 3 times -12 is -36. Now, I'm going to use these two equations. I see right here, boom, I got a zero pair. So those zero away. 15 plus 4 is 19x. -2 plus whoopsie, 36. Again, I'm using my calculator. Every opportunity I get is -38. When I divide both sides by 19, I get x equals -2. Am I done? No, I'm not done, because I have to figure out what y is worth. So I'm going to go back to this equation. 2x plus 3y equals -1. Well, -4 plus 3y equals -1. 3y equals 3. Y equals 1. So right now, I think x is -2 and y is 1. And again, I got another equation right here that I can check with, so I'm going to. 5x, which is -2, plus 3 times y, which is 1, should equal -1. Oh, golly, I just skipped between them. I'm sorry about that. Let me erase that. That's just a crazy person mistake. Okay, see, we make mistakes. That's why we have erasers. Okay, yeah, Glad I caught that. So 5 times x, which is negative 2, minus 2 times 1, should equal negative 12. Well, 5 times negative 2 is negative 10. Negative 2 times 1 is negative 2. Negative 10 minus 2 is negative 12. That is a true statement. So negative 2, 1 is my solution. Number question, number answer. Okay. Take a minute. I want you guys to try the next one and see what you get on this one. This one's actually pretty easy. Okay, when I look at this one, I see I've got a single 1y and I've got 3y. So I could easily make a zero pair right here by multiplying this row by negative 3, because then I'd have negative 3y and positive 3y. So I'm going to do that. That saves me some time. Negative 3 times negative 7x is positive 21x. Negative 3 times times 1y is minus 3y. I don't know what negative 3 times negative 19 is, so I'm going to let my calculator do that. 57, so that equals 57. Okay, now these are the two equations I'm working with. 21 minus 2 is 19x. These zero out. Negative 19 plus 56 is 38. Now I'm going to divide both sides by 19. Oh, hey, look at that. Same numbers, but never mind. This is positive 2. So I have x is positive 2 is what I think the answer is. Now I'm going to go back through and I'm going to substitute, and I'm going to find out what y is. Negative 7 times 2 plus y equals negative 19. Negative 14 plus y equals negative 19. I'm going to add 14 to both sides. Y equals negative 5. So right now I think 2, negative 5, but I like to get the answer right, so I'm going to check with this last equation I have here. Negative 2x plus 3y should equal negative 19. So negative 4 minus 15 equals negative 19, which is a true statement. So my answer is 2, negative 5. Number question, number answer. Okay. We're going to go ahead and we're going to skip this one. We're going to do plenty of you know what? Actually, no, we're not going to skip that one. Let's do that one. Okay. So what do I want to multiply this by? Do we care? I'm going to tell you right now, I see these opposites, and I see that these are the small numbers. They don't have anything else in common, but I see that they are small numbers, so I know that whatever I multiply them by, it's not going to be too huge. If I had to deal with, no. So I'm going to multiply the top row by 5, the bottom row by 2, because these are already opposite, and I get 10x plus 40y equals 30. Here I get negative 10x minus 40y equals negative 30. How about that? Okay, well that zeroes out, and that zeroes out, and that zeroes out. So a lot of you at this point, you freak out and you go, oh my gosh, there's nothing left. What do I do? How do we mathematically represent nothing? With a 0. On that side of the equal sign, over here I got 0. Does 0 equal 0? That is true, so this is infinitely many solutions. So real quick, let's jump down here. What does it mean that, how can we tell that we have infinitely many solutions? Well, first of all, we know that we have infinitely many solutions because we have eliminated, let's put a little, like a bullet point, eliminated all variables, and our remaining equation is true. Okay? But what is it going to look like? How will I know that I have infinitely many solutions? What does that tell me? It tells me that the equations are equivalent, and it tells me that I have one line. Well, actually, I have two lines graphed on top of each other. Okay. Now I want you to really quickly write down what you think it means that let's say if. What does it mean if our system has no solutions? So you should be able to kind of like think about this. Now, we know, think about this, write down what you think it is, and then we'll talk about it. Okay, so if our system has no solution, that means we eliminated all variables and our remaining equation is false. Now, of course, that means the equations aren't equivalent, but on the graph, what it means is we have parallel lines, okay, and they will never cross. Okay? So we're going to do this example together in class tomorrow. So I don't want you to worry about this one right now, but if you want to give it a try, you can. This is actually, I might solve this with substitution. I'm not sure. So let's take a look at this one and see, and we'll look at this one in class tomorrow and see how we would solve it.